Alright, this is the second video on solving systems of nonlinear equations. If you haven't seen the first one, please do that before you watch this one. This is a continuation of that video. So the second example I'm going to do is this system right here where x minus 2y equals 1. We have a linear equation there, and y equals the square root of x minus 1, which is a square root function. I'm going to solve this in two different ways. So my first method is going to be, both of which are substitution. The first way I'm going to do this is by taking that equation on top and solving for x. So method 1, I'm going to substitute using x equals 2y plus 1. So that's the first equation. I'm going to take that expression and sub it in for x in the second equation. So that will give me y equals the square root of the quantity 2y plus 1 minus 1. Simplify the right-hand side a tad bit. That gives us 2y. 1 minus 1 will give us 0, so that cancels. Now to solve for y, I need to take both sides and square them. That gives us y squared equals 2y. Subtract 2y from both sides. Factor out the y. And zero product property gives us y equals 0 and y equals 2. Now we still need to find x. And to solve for x, I'm going to take, let's see, the first equation is easier to sub into for y. So I already have this equation right here. I'm going to take that and sub in 0 for y, which will give me x equals 1. So that's the ordered pair 1, 0. If I take this y value, same equation, x equals 2 times y is 2 plus 1 will give me 5 for x. So I have the ordered pair 5, 2. Notice I have two solutions to this system. So if you look at this graphically, you have your square root function y equals square root of x minus 1. Let me show you in Desmos real quick. And there it is. So you have this point right here is 5, 2, and here's the vertex of that square root function at 1, 0. Right, and the third example is going to be this system, 2x minus y equals negative 3, and 2x squared plus 4x minus y squared equals 0. You won't recognize this second equation, but that's okay. You don't need to know what it looks like necessarily. We're just going to do this using substitution. So I'm going to take that first equation, 2x plus 3 equals y, solve for y. I added 3 to both sides and added y to both sides. I take that expression and substitute that for y in the second equation. So that will turn into 2x squared plus 4x minus the quantity 2x plus 3 squared equals 0. Now be really careful with this quantity, so square that. And then there's a negative sign in front of it, so keep it in parentheses when you square that binomial. So that'll give you 4x squared plus 2 times 3 is 6 times 2 is 12x plus 9. Feel free to write that all out and expand and distribute if you need to. Distribute that negative sign in there. That'll give me 2x squared plus 4x minus 4x squared minus 12x minus 9 equals 0. Combine like terms, negative 2x squared minus 8x minus 9 equals 0. make this slightly easier on myself, I'm going to multiply through on both sides by -1 to get a positive expression on the left. Just makes it easier to solve the quadratic. Now I know this quadratic is not going to factor because 2 times 9 is 18. There are no factors of 18 that add to 8. So I'm going to jump to the quadratic formula. -8 plus or minus square root of 64 minus 4 times 2 times 9 all over 2a, 2 times 2. If I look at the discriminant here, I have 64 minus 72 is -8, which will tell me that there are no real solutions to this quadratic. And since there are no real solutions to the quadratic, it goes to show you that there is no solution at all to this system of equations. Again, you can look at this graphically on Desmos and see what this looks like. It's going to be an interesting graph that you'll learn about next year in pre-calculus.